Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 5.2 entitled Point Slope Form. And today we're going to be given a point and a slope, and we'll have to write the equation of a line in point slope form. And then we're going to rewrite that equation in slope intercept form so that we can see the connection between both of the forms. And then we'll also be given a point and a line, and we'll have to write an equation that's parallel to the given line. So that's an application of the point slope form. So before we get into all that, we have to look at the actual point slope form. And here it is. Y minus y1 equals m times x minus x1. Now, the y and the x will stay y and x in the equation just like they did for slope-intercept form. And the m is still going to be slope, just like it was in slope-intercept form. The two new pieces are the y1 and the x1. And that just means that not only are they different from the x and the y, but they are an ordered pair. So they will be, oh boy, an ordered pair, x1, y1, that we will either find off of a graph or we will know based on the information that they give us. So we're going to use a point and a slope in order to write the equation of the line. So this equation is used when we know the slope and a point that the line goes through. And the nice thing about it is that it can be solved for y so that it's in slope-intercept form. Y equals mx plus b, which is what we talked about in the previous section. So that's the nice connection between these two equations. So for example 1, they're just going to give us a point and a slope, and they want us to write the equation in point-slope form. So let me write our general form here. Y minus y1 equals m times x minus x1. And until you get really good at memorizing this formula, write it down. So that way you're substituting the right pieces of information into the right spots in the formula. And I'm going to label my ordered pair x1, y1, so I know where those get substituted in. My m for my slope is going to be given to me. So now I'm going to substitute in the point 1, 2, and the slope. So I'll have y minus 2 equals 4 times x minus 1. And that's it. You're done. That's how an equation looks when it's written in point-slope form. Now that really doesn't help us a lot. I mean, we can tell what the slope is and we can tell what point the line goes through. But if we were going to graph it, it's not the most user-friendly. So let's try it again for part B. Let's just practice writing it. Okay. I'm going to have x1, y1, and my slope. Now I have the general equation written over here, so I'm not going to write it again. But I'm just going to substitute in. So we'll have y minus 0 equals negative 2 times x. Now the equation has a minus in there. So if I'm going to subtract a negative value, that's going to be adding 3. And that's all we have to do for this equation. We're just substituting the information into that form. So we're getting used to working with the point-slope form. Okay? Now in example 2, we're going to do that same thing. We're going to substitute in the information, and then we're going to solve it so that it's in slope-intercept form. So remember, it's y minus y1 equals m times x minus x1 for our point-slope form. So I have x1 and y1 and my slope. So I'll start by doing y minus a negative 3 would be plus 3 equals my negative 1 for my slope, and then x minus 9. Now, I have to put the equation in a slope-intercept form. Remember, that's y equals mx plus b. So that means I have to solve the equation for y. So I'm going to distribute the negative 1 So I'll have y plus 3 equals negative 1x plus 9. And then I have to finish getting the y by itself, so I'm going to subtract the 3. I'm going to move it over to the opposite side. So y equals negative 1x plus 6. So now I've really written the same line in two different forms. I've written it in my point-slope form, and I've written it in my slope-intercept form. So it's the same information, it's just reorganized in a different format. Okay, so let's try that again for part B. So I have x1 and y1, and then there's my slope, which is 3. So I'll have y minus 4 equals 3 times x minus a negative 2 is going to be plus 2. And then I'm going to distribute. So y minus 4 equals 3x plus 6. And then to finish solving for y, I'm going to add the 4 over. So y equals 3x plus 10. So again, I have the same equation in two different forms. I have my point-slope form and then my slope-intercept form. Same equation. If I graphed them, I'd get the exact same line. It's just an equivalent version of the lines. Okay? Now for example 3, we're still going to write the equation of the line in point-slope form, like we did in example 1 and in example 2, except I have to find out the point and the slope from the graph. So I need to find at least one point. I mean, I really need 2 so I can find my slope, but I need at least one nice point on the graph somewhere that the line's going to go through. And then I need another one so that I can count my rise over my run. So let's see, if I look at this graph and this line, I need a couple nice points. And again, by nice points, I mean where the graph grid and the line meet. So it looks like there's one right there, and maybe one right there. Okay. I could probably use this one as well. Okay, but I only need 2. So you can pick any of those 2. You could pick the first one and the middle, second one. You could pick the second one and the third one. First one and the third one. Doesn't matter. Okay. So my first ordered pair here, let's see, that's 1, 4. My other ordered pair looks like it's 5, 1, 2, 3, 4, 5, 6, 7, 5, 7. Okay. Now, I need a point and I need the slope. So I can use either of these points in my equation, and I need my slope, so I have to count. I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. So my slope is going to be 3 over 4. Now this ordered pair over here, 1, 2, 3, negative 3, 1. That's negative 3, 1. I could use any of those points when I'm writing my equation. Okay? Doesn't matter which one. So if you picked negative 3, 1 and somebody else picked 5, 7, your equations might look a little bit different, but when you resolve them in slope-intercept form, you will all get the exact same equation. So you just need to pick a point. I'm just going to pick 1, 4 just because it's nice, small numbers. They're easy to work with. They're positive. I don't have to worry about negatives. And then I'm going to use my slope. So y minus my y value is 4 equals my slope 3/4 times x minus my x value was 1. Here we go. I wrote the equation of the line in point slope form. That's all I had to do. I don't have to solve it for y and get it in a slope intercept form. I can just stop right there. So this type of a problem is really just making sure you can pull the information off of the graph. So let's try this again for part B. I need to find at least 2 points on the graph that are nice. There's one, there's one, there's one. Oh, this graph has lots of nice points on it. Okay, So, um, let's see. I've got, what is that one? 0, -2. I've got 1, 1, 2, 3, 4, 5. 1, -5. I've got -1, 1. I've got, what's this one? 2, -8. So I have lots of points that I could use to write my equation. And I need at least 2 of them so that I can count my slope. Looks like my slope is going down 3 and over 1. Down 3 and over 1. Good. All of these are down 3 and over 1. Even here, down 3 units and over 1. So my slope is going to be -3 over 1. So again, I'm going to use my slope and one of the points. Again, it doesn't matter which point you use. Let's use one with a negative this time. Let's use 2, -8. Okay? And then I'm going to write my equation. Y, let's see, minus a -8 will be +8 equals -3. And I could put -3 over 1, or I could just put -3 times x minus, my x value is 2. And that's all we need to do. Now, if somebody else picked a different point, if somebody picked -1, 1, they would have y minus 1 equals -3 times x plus 1. So the numbers for the x and the y, the x1 and the y1, might change, but when you distribute and then subtract the 8 over or add the 4 over, you're going to end up with the exact same equation as somebody else will have once it's in slope-intercept form. Okay, example 4. I believe this is our last example. We're going to write in slope-intercept form now. Remember, slope-intercept form is y equals mx plus b. Okay, so we're going to write in slope-intercept form the equation of the line parallel to the given line, so parallel to that line, and it goes through the given point. Okay, so when they say lines are parallel, that's really a mathematical clue. They're giving us a little hint that we have to kind of decode. Anytime lines are parallel, remember, that means that they have the same slope. So really, when they say that the lines are parallel, that's telling me I'm going to use the same slope as the equation that they gave me. And then I have to also go through the point that they gave me. So I have a slope and a point. So I have point-slope form that I'm going to be solving with, or starting with, and then I'll resolve it so that it's in slope-intercept form at the end. Okay? So let's look at my part A here. The slope of this line is going to be the -2. So I'm going to use that value since they're parallel. We're going to use the same slope. And I'm going to use my ordered pair of 3, 4. Now, don't get confused by the notation here. Okay, this little comma is just separating your line from your ordered pair that you're going to be using. So I'm going to start with point-slope form. And I'm going to start with point-slope form because I have a point and a slope. Okay, so the name is very easy to remember when you need to use it. Anytime you have a point and a slope, you use point-slope form. Now, I have to get my final answer in slope-intercept form, so I need to do what we did in example 2, where I distribute and then solve for y. So -2x plus 6, and then I'm going to add the 4 over. So I will end up with y equals -2x plus 10. Now that equation should be parallel to my other equation. So it has the same slope as the one that they gave me, but my intercept is different. That's good. I don't want them to be the same because then they would be the exact same line. They'd be on top of each other. Okay, so let's try that again for part B. Okay, my slope is going to be the 4. So I'm not using that -3 at all. Okay, that's just another intercept. I don't need to use it in my calculations at all, but I do need my ordered pair. So there's my slope and my point slope form. I wrote the generic or the general form over here, so I'm going to just substitute now. So I'll have y minus 1 equals 4 times x minus a negative 4 is going to be plus 4. So I know we have two 4's here. This 4 goes in there for the slope. Oops. This 4 goes in here with the x. Okay? All right, now I have to distribute and then solve it in, or put it into slope-intercept form. So I'm going to have 4x plus 16, and then I'll add the 1 over so that the y is all by itself. 4x plus 17. There we go. Now again, remember, just like in example 2, this equation in the point slope form and this equation in the slope-intercept form, they're the same information, the same line. They're just two equivalent forms for all that information. And again, like in part A, we could double check here. This answer that I have should be parallel to this other line. So let me erase this that I crossed off there. My original line was y equals 4x minus 3. Now I have y equals 4x plus 17. So they both have the same slope. It's a 4x and a 4x, but the intercepts are different. So again, I don't need that negative 3 to do the problem, but it's good to double check that it's not the same value in my answer as what I started with up here. So there's a lot of little steps in these types of problems. You definitely want to practice this homework. Write down the equation for slope-intercept form, write down the equation for point-slope form, label your ordered pairs, and practice these problems. If you have any questions, come on in and see me before school.